Okay. So let me start. Welcome with this session about Red Hat OpenShift and a little bit about DevOps again. Containers and serverless in a hybrid world. Let me start. My name is HOEFLAKEN. I'm from Axians, the Netherlands. And although I'm here, I'm told, in a more infrastructure kind of track, I'm actually a dev guy and not an ops guy. My role is solution architect and a technology lead of Axians Integrated Solutions in the Netherlands. So, anybody knows what a container is or has worked with containers or... Yeah? Quite some people. Okay, so I'm going to give a sort of a definition that I think is not the actual truth, but it's good enough for this presentation. If you have not worked with containers. If I press the right button. A container is somewhat like a VM, but it has some characteristics which are different. First of all, it doesn't have any hypervisor. It does not require any OS, and therefore it's much smaller and it's much faster in startup. And it's therefore also much easier to move around, and it provides you with better hardware utilization. Because I do not have a VM with an operating system which runs a small Java application, which takes a lot of overhead, which you don't have if you have a container. So, serverless. So I explain as serverless that it is actually a container which spins up very, very fast. It gets a request, then it spins up, it does what it has to do to fulfill and process the request, and if it's done so, it will automatically scale down and disappear. So it only takes the resources that it needs to actually process a request, but it won't be polling or when it has nothing to do. So it doesn't consume any resources if it hasn't do anything. I think you're familiar, with the signs which are below of Azure Functions, which is an example of serverless, and the lambda from AWS are examples of it. And it gives you another abstraction layer for the developer, because with containers I don't have to think about VMs anymore, but with serverless I don't have to think about containers anymore either. I'm just thinking about the code. I write some code and I just deploy it anywhere, and someone is taking care of the container and the VM part of it. So what is OpenShift then? OpenShift is a hybrid cloud container orchestration and DevOps platform. So the first part is the same actually as Kubernetes is, and OpenShift is a certified Kubernetes implementation, as Wian said. But on top of that, it also provides a lot of functionality to actually develop applications. And you can imagine, why do I need a container orchestration layer? Well, you could imagine, just like in a harbor, if you have just one container, then it's no problem. But if you have hundreds or 1,000 of containers, then you have to have some platform to move those containers around, to monitor them, etc., etc. And that's what OpenShift or Kubernetes actually does. So, how does it work? Well, I hope that this works, but actually, OpenShift works with projects. So you create projects and you assign people to those projects. So they have to authenticate themselves and they have access to one or more projects. In this case, is only access to one project. And within a project, you can define which kind of technologies programmers or developers within that project can actually use. So, I'm going to hope that this works. Where's my mouse? Yep. I practiced all my short keys, so it should work. This is the developer. You can see only one project that he's allowed to do something with. Then I'm going to log in as myself, and you will see that I've got a lot of more projects at the right side. As you can see, I just recorded. I didn't want to try it out live. So multiple projects, and now I'm going to say, okay, I'm going to my project, and within that project, I'm going to browse the catalog to create a new instance of a MongoDB because I want to develop an application with a MongoDB in it. So a wizard is started. I just provide some information that is needed. So I have to provide a connection username and password, and a password for the admin, and then I can create the actual container by clicking the create button. And by doing so, it will spin up a MongoDB container for me. So there's no process I have to go to. I don't have to ask anything, anyone, and it will automatically spin up. And eventually it will turn blue, stating that it is running. So now I've got a MongoDB running. I don't have to ask my operations guy. My operations guys already allowed me to do so because it gave me access to a project which has the MongoDB in it for me to use. So there's no delay there in development. Okay, so the next part that I want to show you, because we're going through some of the functions of OpenShift today, is the CE/CD part. But so I've got an application. It's a very simple application, and I've got two versions of it. One is let me check that it is running. One is on the development, and I've got the same application in the staging environment. Both are version 1.0, and it is a very impressive application, because if I press the log info button, you get an informational message was recorded internally. Very brilliant. So if I go to the next step, which is in the staging environment, then you will see that it's the same application. So there you see that it's the staging environment, so it's another URL, but it's the same application, and if you press the log info button, you get the same application. So I've got the same application running in staging and running in development. Now, as a developer, I have to create a change. So I open my web browser. It's not Visual Code, what you saw before. This is Eclipse GA, but it's fully browser-based, running in this case on OpenShift as well. I changed the message, I increased the version to 2.0, and then I'm going to commit to Git, in this case, my changes, so that my change becomes available within the repository for other developers to see as well. I gave it, of course, a brilliant comment, and then I push it. And what happens then is that, because the same what you said, I don't know if you were in the previous version, but because I do a commit, a new pipeline will be started to actually build a new version of this application. So we are using Jenkins for this. It first turns gray to show that it's now actually creating a container for the actual pipeline to run in. If it has created a pipeline, it will then start with the actual build of the application. So it retrieves the source code from Git, and it will then compile it, in this case, into a Java web archive. If it has completed that step, it will start with actually unit testing, automatic unit testing of that same application. If some of the tests fail, then the pipeline will stop, and you have to make sure that they don't fail to continue. But in this case, everything goes well, so the test will be green, or will be very surprising. But then the code analysis will be done. So this is the, in this case, we do use SonarQube, and within SonarQube we have defined all kind of quality rules that we want to check the source code with, such as coverage, test coverage, vulnerabilities, etc., etc. If the code analysis is done, then the app will be archived, which means that the actual application that we build will be put in a Nexus repository, so it is available for all kind of other people. And now it's building the actual image, and because it's taking the application and puts it in a container, and now you see that the old version is on the left is still running, and while it's still running, it is spinning up the new version on the right. And eventually, if that one is running, it will scale down the other one. So there's no time in between that you don't have any access to the application. It's always on, so to speak. So now we go back to the one, and now you see that the subversion increased in the left top to 2.0, and if I press the plugin button, you have a new, the new version, so to speak. So, in between we had all kind of steps. One of them was, in this case, the quality check, the assurance. So this is SonarQube. So it shows, for example, that although the code was running, I probably have two kind of bugs, and I was classified as the quality as C. I've got a vulnerability. I did well on maintainability because that's class A, although there were, well, about 17 code smells. About testing was not that well, only 60.3% of the actual code was covered during testing. And another thing that you could see, where's my mouse? Is that on the other one, is on the issues tab, then you see all the issues that there are with your code, and you can use those comments to actually improve the code. So this is something that operations, for example, can use to control that what someone builds actually has a certain quality in it. So this is also tools to work together with developers and operations. Another tool was Nexus, as I told. So here, what you see here is that the actual version is deployed in a Nexus repository so that other people can retrieve it if they want to use it, so they don't have to build it themselves. And the actual image is stored also in a repository or a registry, a container registry, so that other ones don't have to build a container themselves but can use it. But I'm using Red Hat Quay, and those Red Hat Quay also scans the actual image for vulnerabilities. So you see here that my image is using quite some packages, but there are also some which have high, medium or low level vulnerabilities. It doesn't automatically update the image to do so, because that would require that you test again, because then something has changed within the environment. So knowing that, I want to go any further, and this is to show you that it's not always completely automatic. In this case, we have defined within our pipeline that someone has to actually manually approve the application to go into the staging environment. So I'm going to improve it, I hope. Yep. I'm going to promote it, so now it's going to promote it to the staging environment, and it's going to deploy it. And now I'm clicking to show you that I'm clicking while OpenShift is putting on the new version of my application. I have no 404, but I've got my new application. So this is another way to show you that it doesn't have any downtime. I can keep on sending requests while I'm deploying the new version, and if the new version is available, then it will automatically switch to the new version without any downtime. So that's about this one. Okay, so I also wanted to show something about testing, and to do that we need to talk about a little bit about how OpenShift works internally. As I said, OpenShift works with projects, and a container or more containers can be in one project, but a container is not addressed directly. It's always done by a so-called service. So if a container B wants to call an API which is implemented on container A, you have to go by the concept of a service, and that's because OpenShift can scale up and scale down your containers automatically or manually. Automatically, for example, if it sees that your container is getting a lot of requests, it can spin up another instance of it so that you can distribute the load, and the service is some kind of load balancer in between. If you want to expose the actual API, which is on container A, to the outside world, then you have to implement a so-called route, which gives you that others outside the actual project can access your container. Well, you can use that route to actually implement blue-green deployments. Anybody knows about blue-green deployments? No? Okay. Blue-green deployments is that you have, that's what you saw earlier, you have your version running, which is available for your customers. You are bringing up a new application in your production environment, but it's not accessible to the outside world yet. You are going to test it and verify that everything installed okay, and if it's all installed okay, you only have to switch the router, which is in milliseconds, and then you have the new version. If you then see that there is a problem, you switch back again. This is something which is used by a lot of the big companies like Facebook, etc., because they do testing, but they do a lot of testing within production itself, because they have, within milliseconds, they're back to their original version, so there is no real risk there. Another type of testing is so-called A/B testing, and that's what you use to test new kind of functionality but won't expose to your whole consumer base. This is something which is used by Facebook, etc., all the kind of applications as well. So in this case, 90% of the customers will go to the version 1, but 10% will go to version 2 of your application. So, how does that look like? I've got a version here of the same application that I have, a version 2 and the so-called latest version. Both are running. And, so I will go to the route, and then you will see that it's equally distributed. So 50% will go to the one version, and 50% will go to the other version. This is another way that you can see that with a slider you can just adjust the amounts for it. So what I'm going to do now is I'm going to open a new browser fenster, and then you browser window, and by doing so you first will see that a version 2 of the application is opened, and if I close this browser window and I do it another time, you will see that a version 3 is open. So using the same URL, you actually see that the routing is balancing between those two versions. Why do I need to close my browser?
The session?
Yes, it keeps safe the session. So it knows if I was on one version of the application, it will always stay on the same version. And that's actually a good thing, because I don't want to go, if I'm in sort kind of wizard or something like that, that I'm switching between applications. So it's keeping stable. Another thing is that we can manually scale up version 2 of the application, and then it will create 2 instances, and I have nothing to do with it. So it's just a click of a button, and the second instance of the application is actually running. Okay, so I'm doing about time.
5 minutes.
Oh, okay, that's okay. So, what are the key takeaways? First of all, before I forget, if you want to play around with OpenShift, go to learn-openshift.com.
Learn.openshift.com,
yeah, that's the website where you can try it for free. There is all kind of guides which will guide you, and tutorials which will guide you to the different steps. But the key takeaways are that it is a container and serverless orchestration platform which provides you with DevOps. It provides you with auto scaling, that's what we saw. We saw a little bit about green and blue deployment and A/B testing, but it has a lot more. It has metrics, and based on that metrics you can do scaling. It has logging, security, all kind of things on top of Kubernetes to develop your applications. And one very important thing why we use OpenShift is that its complete stack is managed by Red Hat. Because if you take a plain Kubernetes and then you're going to do your own kind of app development stack on top of it, it's very hard to maintain. So that's something that we decided we won't do that. We have a vendor for that, that's Red Hat, which provides the complete stack and maintains it. We just focus on creating value. And another important thing is that's cloud independent. So I can develop in one way, and it doesn't matter if it runs on AWS, on Azure, on Google Cloud, or on my private cloud, or even on bare metal. It's the same development model. And you can use it anywhere. So Azure Functions is fine, but it doesn't run locally. Although within a few months, I believe it will run locally, but LabDAS won't run locally, for example. But if you define a serverless function on the OpenShift platform, it will run anywhere serverless. So you build once, you deploy it anywhere, and you decide which tools you want to use as an organization and where you want to run it. So that's about it. Any questions?